Hey guys, welcome to this session by Intellipaat. Seaborn is one of the world's most famous data visualization tools out there. With this comes a greater demand for it to be used to solve problems across a variety of domains. And in this Seaborn tutorial, we're going to check out all the details on how you can get started to learn Seaborn and more. Well, before we begin with the session, make sure to subscribe to the Intellipaat YouTube channel and hit that bell icon so that you never miss any updates from us. Now, coming to the agenda of the session, we'll start out by taking a quick introduction to what Seaborn is. After that, we can check out why there is a need for Seaborn and how we can plan to get started with it and how to get started to actually use Seaborn practically. With this, we can understand why we require Python for data visualization, and at the end of it, we'll check out a comprehensive hands-on use case demo where I'll be walking you through all the use cases on which Seaborn is very well known for and how you can get started with it easily as well. Well, guys, without further ado, let's begin the session.
First thing I want to ask is, did you actually know this? The human brain processes images 1,000 times faster than numerical data. So think of this exact situation, right? So let's say you have an Excel sheet with probably 2,000, 3,000 rows and columns worth of data. And as soon as you look at it, you might not be able to make sense. But then when you go on to create a graph out of it, or multiple graphs for that matter, then you can, make a lot of sense out of it, right? And I'm sure you've been in this spot and you understand this as well. Now, when you think about data visualization, right, Seaborn is a data visualization tool. One very important thing is today's world is driven by data and even all the businesses, right? So when you look at it, everything from a startup all the way to a trillion-dollar business is actually driven by data. Data is considered to be the new oil, and we have to, sort of refine it, understand it the best we can, and leverage it either for business, either to drive insights, either for medical purposes, whatever it is, right? So one thing with data and data analytics with respect to data visualizations is that you can drive a lot of insight without actually putting any considerable amount of effort. So it's an easy thing to do. You're going to drive a lot of businesses, you're going to add a lot of productivity, and at the end of the day, it's a win-win-win no matter how you look at it with respect to data visualizations as well. So with this, let's come to a quick introduction to what Seaborn is. Seaborn is a data visualization tool in Python. So as a data visualization library, Seaborn is considered to be one of these amazing tools that's actually built on top of another library called as matplotlib. So Seaborn is an extension of matplotlib in a way where it adds more aesthetics, in a way where it adds more ease of use to the already existing matplotlib, which again, I'm sure if you read this video, you might have heard of matplotlib, and there's a good chance you know that it is again a beautiful looking library where you can work with a lot of things and you really don't have to put a lot of effort. So it's nice to work with, it's easy, and if you love data and visualizations, you're going to thoroughly enjoy the Seaborn tutorial, guys. Well, this is how the pipeline works, right? So this is a very simplified pipeline. So take a look at it. You will find data from multiple sources, be it Excel sheets, be it data from your client's place, be it data on the cloud, be it data anywhere else, right? So data from multiple sources is brought into your company or into your business by a data engineer or so, and then the data scientist sits there and data scientist performs all of these analytics. A data scientist adds algorithms to make sense of this data and then pushes it on to the data analyst team. And you as a data visualization person is a key part of the data analyst team, because in a way with visualization, what you're trying to do is you're trying to make more sense of data aesthetically and in fact, and you have the ability to drive detailed analytics in a way where you will not have to put in much effort, but you can see hidden insights and treasures that lie within the data, which you might not see as soon as you look through it through the naked eye as well. So with respect to that, Seaborn is an amazing tool to use. So why would one go on to choose Seaborn, right? So Michael Wascom is the creator of Seaborn, and he says and affirms to a lot of Python users and a lot of data analysts across the globe that Seaborn tries to make hard things very easy to use. And see, in the world of programming, this is a very bold statement to say, and it's not just Michael who says this. It's a lot of people. It's hundreds of thousands of developers across the globe who actively contribute to Seaborn because it's an open source library, and at the end of the day, it's a common consensus that this is an amazing tool to use. And as soon as we move to the hands-on section at the end of this presentation, you will understand why I'm just saying it's this easy and this fun to use as well. But then at this moment of time, you really have to understand that it's a very powerful visualization tool, and do not be fooled for a second thinking that it is easy, so it's not powerful. Absolutely not. That is the huge advantage when you're working with Seaborn. So now, to understand why you have to use Seaborn, you have to compare it with Matplotlib. Only then you will understand what Seaborn brings to the picture, right? So you cannot have a total head-to-head comparison with respect to Matplotlib, because Seaborn is actually built on top of Matplotlib. Matplotlib serves as the foundational library on which Seaborn is built upon, and eventually it's an extension of Matplotlib, if I have to put it that way. But then there are certain differences, and at this point of time, you have to know this if you're looking towards Seaborn as well. So the first most important thing is that Seaborn has a high level interface through which you can work and write code in, while Matplotlib, you really have to think about working with a low level interface. See, the level of interface what we talk about is how easily you can work with the syntax, and how easy is it for you to teach, or in fact convey to the programming convey to the interpreter on what needs to be done how. If it's easy, if it's readable, if it's very similar to common English language, it's a high level interface. If you really have to dig into the details, put in a lot of effort understanding the syntax, put in a considerable amount of time knowing what the syntax does and eventually doing it, well, Matplotlib does that. And if you're beginning to learn Seaborn, this might be a very a big turn off or a disadvantage. But then do not get me wrong here, Matplotlib and both Seaborn are amazing tools to use, but just that with respect to its level of being user friendly, I would say Seaborn wins out here. In fact, even in our hands-on, let's compare what Seaborn and Matplotlib are there. So make sure to stay tuned to that. And then think about the theming, think about the beautification, think about the aesthetics, think about the control you have over your graphs and visualizations. See, Matplotlib and Seaborn, both of these are data visualization tools. It's going to take in certain numbers, it's going to crunch these numbers, and it's going to give you a beautiful looking graph. It's going to give you an entire sheet full of graphs, or it's going to give you a lot of plots, hence the name Matplotlib. Having the ability to theme it, having the ability to customize it, and having the ability to do this easily, this is where Seaborn wins. Matplotlib, of course, can do it to an extent, but then it takes a lot of work, and it's not just a lot of work to just have a basic graph or a plot, but then it takes a lot of work to make those plots look aesthetic as well, right? So in today's world, when you're in a business meeting, when you have to pitch the productivity, when you have to pitch the analytics aspect of things to a person who is not into programming, who doesn't like to see numbers, right? So let's say you're in a meeting, rather than showing them an Excel sheet, you would rather present them with beautiful looking graphs to tell them this is where we are, this is where we should go, and all of that, right? Think about it for a second. And this is where Seaborn wins, in my opinion. And then when you think about it, right, a very important thing, if you've used Python and if you've used pandas, if you've used all of these other libraries that are dependent especially to provide data for these data visualizations tools, you will understand how important it is that these tools can understand data from a variety of sources, right? For example, think about data frames. You might have used data frames in the past, but then if you've tried to use it with the Matplotlib functions, there's a good chance you cannot use it at all. But then even if you do, it's very complex to work with, especially huge data sets and data frames as well. So in that aspect, again, Seaborn has the capability to handle all your data frames very well and cope up with all of that as well. So in terms of developer productivity and in terms of the basic ability to support another library hand in hand, Seaborn wins, in my opinion. Now, after you have understood what Seaborn is, how does it compare with Matplotlib and more, you will have a question saying, okay, I'm on this video and I want to understand how to learn Seaborn. Well, guys, I'll not let you wait any further, because you really have to know how to learn Seaborn in a structured way. Well, let me tell you this. It is very similar to learning any of the other libraries in Python, or in fact any other library of any programming language as well. Firstly, you have to take a practical approach, guys. So you cannot sit and read theory and say, you know what, I'm going to implement all of these later after I finish the theory. That really will not work, because I'll tell you why. See, the first thing you'll have to do to become an expert in any of these libraries, which might get complex along the way, is to have a strong foundation. And you can build your strong foundation by learning in context. Like you're learning a concept, you're implementing it, you're learning it, implementing it, and on. So to begin all of these procedure, right, so your step one will be to install all of the dependencies, install Seaborn, and to use Seaborn you have to install other libraries as well. I'm going to walk you through that in a second, but then the step one is this: you have to install all of these, and only then you can work with them side by side, right? So it's pretty common, and you know that by now. Step number two is to understand the basics and the paradigms of Seaborn. See, you have to know what makes Seaborn what it is, rather than what makes Seaborn stand apart from, let's say, Matplotlib or any other beautiful visualization tool out there. Because if you're honed in on Seaborn, you need to put your time, you need to put your effort into understanding how it works thoroughly. After you understand how it works, then step number three is concentrating on a data set. Take up a data set. Let it be a basic one. You really do not have to start with a very complex data set and overwhelmed and feeling like Seaborn may be a lot for you. And of course that will not be the case, and you will see why, because I have a data set for you guys and we will be working on that. But learning in context by making use of a data set will concrete your learning in terms of practical application along with theoretical learning as well. And of course there's always the last step. In fact, in my opinion, a very important step that a lot of people tend to skip is to go around communities, talk to a lot of people who have used Seaborn, make contact, leave them a message, ask them about their journey into Seaborn, see what projects that they're doing, see if you have an idea where you have a lot of data and you want to convert it into visualizations, right? So you can put your ideas into fruition by making use of this. You can implement your projects, you can have your ideas customized, and in fact you can outsource yourself to other people where you can implement their ideas as well, right? Think about it in an experience standpoint, think about it in a monetary standpoint. Again, it's a win-win with Seaborn. Now, you will have a question saying, all right, I am all set. How do I start with this? Well, let me tell you this, guys. To start with Seaborn, right, you have certain dependencies. It's a data visualization tool in a way where you have to provide it with data, right? So to provide data to it, Python has amazing tools, right? Be it numerical computation or any scientific computation, which requires a lot of algorithms and whatnot. You have NumPy, you have SciPy, and then to handle data in a structured way, you have the Pandas library, a beautiful library to work with, which makes Python the beautiful language that is, in my opinion. And of course, since Seaborn is built on top of Matplotlib itself becomes a dependency for Seaborn as well. So to get started with this, it is vital that you understand the basics of all of these libraries, guys. At this point of time, do not worry in case if you do not have the basics of this down yet. You will see that it is pretty simple to work with it. And of course, while working on Seaborn itself, right, you can work on the data aspect of things and eventually start visualizing it side by side too. But then as of now, understand that these are the dependencies and you will have to install all of them as well. So the next question you'll have is, how do I install Seaborn? Well, it's pretty simple, guys. You'll either use the pip installer, the package manager, to install Seaborn. It's a very simple command, pip install Seaborn. Or in case if you're using the Anaconda interface, using the conda command is very similar. Instead of pip, you just type in conda, install Seaborn, and it will install everything that's required to run visualization as well, right? So that really doesn't take much effort, and I would suggest you guys pause this video right now, install Seaborn in your machines. It's very simple, and I'm going to show you another way where you really can work with an online Python notebook, a Python workbook, where you really do not have to install anything too. I'm going to show you that. Make sure you stick around for just a couple of minutes here. But then before that, right, you have to understand that you have to import all of the dependencies that you've just installed. Just installing it is like, okay, it's on your machine, but then to make Python use all of these, you have to import them into your program. You have to import them into your runtime, right? So that's what we have done on the screen right now. We have imported Seaborn, Matplotlib, Pandas, NumPy, SciPy, and of course any other libraries that you wish to use in your program, or let's say any other libraries that your program itself demands that you use as well, right? So this is a very important step, that you import it and then you begin working with it. But To work with Seaborn, you have certain prerequisites, guys. The first thing is that it is always an added advantage if you understand a bit of computer programming, the basic structure of how a computer programming language works, and the basic structure of even Python will help you a lot. Because Seaborn, Matplotlib, Pandas, NumPy, SciPy, right? All of these are libraries for Python. So if you understand Python, then you can use this as a stepping stone to become a better Python developer, or use this to become a data analyst and whatnot. But to go there, you really need to have the basics of Python down, because even though the syntax of Python is extremely easy, as you'll see in a couple of minutes, it is vital, and more than vital, think about it, it's an added advantage, right? If you already know it, you will have a quick head start to eventually go on and work with it. But then yeah, you will require a certain basic idea of how matplotlib works as well, because plotting a graph is pretty simple, but then you do have to know the syntax on what you're plotting, what type you're plotting, how you can work with the theming, and why the plot shows itself as it does as well, right? So working of basic computer language understanding, Python and matplotlib can be a good amount of prerequisites. But do not worry in case if you do not have either one of these or all of these. Stick with me till the demo. You will understand how easy a data visualization tool like Seaborn is to use. Now, before we jump right in, you need to understand the features of Seaborn, right? So I've been telling you that Seaborn has been built on top of Matplotlib. In case if you had a question saying, hey, can I replace Seaborn completely with Matplotlib, or can I replace Matplotlib completely with Seaborn and not have anything to do with the other? Well, it's dependent. You can just use matplotlib and you can still work with it. But to use Seaborn, you really have to know matplotlib, because since it is built on top of it, well, if you take away the foundation, it really doesn't work, right? Similar principle here. Now, coming to the features of Seaborn, it has a lot of inbuilt themes to work with, beautiful looking visualizations, beautiful looking 2D and 3D graphics are there. You can do a lot of multivariable data analytics as well, right? If it's univariate, it means you're working on one variable. Bivariate is you'll be working on two variables and tracking them actively and driving analytics based on that. And of course, you can visualize all of the linear regression models without having to put a lot of effort as well, guys. Plotting time series data, statistical analytics, and all of the other types of plots is very, very easy in the case of Seaborn. And then when we have to talk about NumPys and Panda, right, the last point you're already very familiar with now, right? So it works really well with all the data handling stuff that Python offers for us, and the other libraries too. So after all of these, in case if you have not had an introduction to Python, you will have this question saying, you know what, even R is a beautiful language to use for data analytics and data visualization, and R has a beautiful data visualization library called as ggplot2 in case if you have used that, right? So you'll have a question saying, why do I have to pick Python? Why is Python amazing for data extraction and visualization? One is that it's very easy to use. You really do not have to put in much effort. The syntax is very easily understandable, even if you're a beginner, or let's say if you're a person moving from another domain. You might be an MBA person, a person in business who loves doing this, who has a requirement to do this. You might be a marketing person. You might be a person who's coming from another programming domain as well, right? So switching to Python is very easy. And after you switch to Python, data extraction and visualization will become very easy as well, guys. And then point number 2 is very simple. It's just that it has a lot of libraries that you can do a lot of things with, right? See, for numerical computation, as I mentioned, you have Pandas, you have NumPy. For data visualization, you have Seaborn, Matplotlib, and it has hundreds of libraries. So I literally can go on for hours and hours talking about the libraries of Python, what it does, and how you can use it. And we can actually have a video on that as well, guys. So if you have any video requests, right, head to the comment section and let us know on what topics you want videos about. So this way we can customize it and we can provide you the best content possible. Anyway, coming back, one important thing about Python is that you will have to write a small amount of code to have a huge result. This is the biggest advantage for whenever you make use of Python for data extraction and data visualization, right? So whatever code you write really won't be lengthy, but whatever results you drive out of that code, or whatever the outcome of that code is, right, that will be huge. So that is why Python has become one of the popular languages, in fact one of the most popular languages languages for data science, data analytics, and data engineering as well, guys. And one last point I have to talk about is Python is a beautiful community. It's an open source language. Most of the libraries, in fact 99.9% of the libraries are open source. So there's a huge community. There's hundreds of thousands of developers across the globe. Interact with them, talk to them, find out about their journey, find out about their tips on how to get started as well, right? Of course, we strive to give you the best content possible, and with the community you can share all of these and tell others about it too, right? So it's all about seeing each and every one of us grow together, guys. And in fact, we have an Intellipaat community as well. So just go to Google after this video, type in Intellipaat community, and you will see that we have experts across the globe and people asking a lot of questions, and people answering these questions and helping each other out. It's a beautiful place to be. I spend a lot of time in the Intellipaat community, so make sure you check that out as well. And now to the most important aspect of this video, right? Let's take a quick hands-on session on how to use Seaborn. And if you're wondering what I'm using here, it's actually Google's Collaboratory. So Google Collaboratory is like a Jupyter notebook, Python Jupyter notebook, but that Google that's completely hosted on the Google Cloud platform, guys. So, when you think about it, you really do not have to install Python. You really do not have to install 100 dependencies to work even with the most complex programs. Even the most complex projects that I work on, there's a 90% chance that most of it I can work with Jupyter Notebook. You can take your code wherever you want. Let's say you're working, from your home on your PC. Perfect. You want to take it over to your phone and do something over there. You want to monkey around with your phone and write a little bit of code like you choose. Of course you can do that. That's the biggest advantage, right? And there's an unspoken advantage here. You're using the thorough power of the world's most powerful cloud platform, right? The Google Cloud platform is extremely powerful. They have a lot of manpower behind the technology, and it just makes things easier, guys. I'll just show you how. So coming to the usage of Seaborn, right? So I told you the first step is to install it. The advantage of Google Collaboratory is that it already comes installed, and all you have to really do is import them. So let's begin. All I have to do is click this play button, and what it does is it imports all of the packages for us. We're importing Seaborn, we're importing Pandas, and we're importing Matplotlib at this point of time. Secondly, as I told you, it's always vital to take a dataset approach, right? Take a basic dataset and work with it. Now, we'll be considering a dataset which is the Now, we'll be considering the iris data set, and I just uploaded the data file for that. So this way, as soon as I click play here, the data set gets completely loaded. sns.load_dataset is probably the most used command for me, especially with respect to Seaborn. So this one command will load your entire data set. Now, to talk a little bit about the iris data set, right? So it is actually a data set which consists of 150 samples of flowers. 3 species of flowers to be very precise. One is the Sentosa, and we have the Virginica, and we have versicolor as well. So what we're trying to do is we're trying to compare a lot of things such as the sepal length, sepal width, petal width, and a lot of other things too. So what does this data set looks like? Typing iris.head will reveal just this, guys. Iris is the name of my data set. .head is basically used to print it out. So as you can see, I have 150 rows of data and 5 columns out here, right? So you can see the type of petals here. There's Setosa, there's Virginica, and of course once you go on to print everything, you're going to see the entire thing as well. But then sometimes, okay, this is a very simple data set. Looking at it will make a lot of sense, and it'll be very easy. But then what happens is that if you have a complex data set, right, you really cannot print thousands of rows and hundreds of columns. So there's a very simple command to use that, iris.describe. Iris again being the name of the data set. Iris.describe will give you an overall high level presentation of what your data is. You will get a lot of mathematical insight from this. What is the maximum value? You will get the deviations out of it. What is the standard deviation? You get the mean value. You get count as in how many values for each of these columns you have, and so much more, right? So iris.describe, or in fact dataset.describe, is a beautiful command to use in all of Python, guys. Now the fun part starts when we go on to start visualizing some things, right? So let's have a visualization. It's called as a swarm plot. It's pretty common, but then it's very easy to use. All it takes is literally one line of code to create a a very good looking plot, guys. So basically, sns.swarm plot, x equal to species, y equal to petal length, and we're picking up the data from the iris data set, right? So x equal to species, we're trying to say on the x-axis plot the species for us, on the y-axis use the petal length to describe on the graph, right? As soon as I hit this, you can see this very beautiful looking swarm plot. It's a basic plot, but at the end of the day, you will get an idea, right? So with each of these species, what is the petal length that's been plotted, and what is the flower that we're trying to match the petal length with, right? As soon as you start marking the x-axis and looking at the corresponding y-axis, you'll understand how many units of data are present there. In fact, how many categories of flowers are present here. 3 categories of flowers. In each category of flower, what is the average petal length, right? You can see the average petal length of versicolor species lies somewhere between 3 and 5, and of virginica, it has a longer petal length. It goes somewhere about 4.5 all the way till 7, right? So it's a beautiful way that you can look at it. And if I scroll up and if I show you this, it's really hard to sort of drive this insight, right? And it took one line of command for us to say, hey, this is the average petal length. You can find a lot more with this, guys. So this is a very simple example, a toned down example, so that even you guys as beginners can pause the video, type this set of code, work with me. So pause as and when you require, and make sure that you can get this as well. So we will make sure to put the data set. It's the common iris data set. You can just google it and you can download it from the first link that's available as well. Now whenever you think about plotting it, right, it always adds value if you can see a lot of graphs and drive a lot of analytics out of it, right? So whenever I teach data visualization to people, they're always excited to see a lot of colorful things happen on the screen, and pair plots is one of these ways where you can use a lot of graphs to map a very complex data set and dial it down in a very simple way, right? Just look at this, guys. My programming line was very simple. sns.pairplot. Pairplot is a type of plotting that we use in Seaborn. Iris data set, what's the hue we're mapping on species, what's the size of the entities, it's 2.5. And very simply, you can see on your screen, right? So I have 12 beautiful looking visualizations, and you can see the color that it's been mapped, right? So all the blues that you see on the screen is setosa, all the orange you see is versicolor, another type of flower, all the other green dots that you see is virginica, right? So you can see for petal width versus sepal length, petal length versus sepal length, sepal width versus sepal length, and sepal length versus sepal length itself, right? So each of these graphs have a common x-axis and a common y-axis, but then the analytics that you can drive on a whole, right, as pairing, especially when you're performing bivariate analysis where you're using 2 variables to drive any sort of analytics, pair plots are amazing to use, guys. So as you can look on the screen, you can do a lot of things with a lot less code, right? So whatever I said about 5-10 minutes back makes a lot of sense now, I hope. Now, all of that is good, but what's the basic difference between matplotlib and Seaborn? The most basic difference is this, guys. I'm going to show it to you, right? Of course, the first step is always to import all of these code. We're going to have to import all the libraries if we have to use it. We had already imported it before in the first line, and it's still going to stay in the same runtime. But then just to keep it a little separate in case if you guys are, writing a program from scratch again, I've just put it out here. And secondly, we have to create some data, right? So let's create some random data and try to see if we can use this random data to create a matplotlib plot for us. Creating a plot basically in matplotlib, so we have 6 lines that's been created out of random data here for us, and do not worry about the data as of now, right? Just look at the quality of the graph. Now let me start using Seaborn. So with Seaborn, the syntax, as you can see, is pretty similar to matplotlib, but at the end of the day, a direct comparison, even in the most simple looking visualization, you can check out that with respect to Seaborn, it looks a lot more aesthetical than a very shabby looking presentation. Of course, I'm a huge fan of matplotlib, do not get me wrong, but at the end of the day, when it comes to making use of aesthetics, why not go that extra step to make it look beautiful, right? You can make matplotlib look as beautiful as Seaborn, but it's going to take a lot of effort and a lot of time. So why put in all of that when you can just use Seaborn, which is meant for that, right? I hope you guys got my point here. And you might be wondering, saying, hey, okay, so what are the other good things that we can do with Seaborn? Guys, we can talk over 10-12 hours to understand in depth about all of the data in depth about all the types of data visualization, theming, customization, and whatnot. But my point here is to not overwhelm you guys. So, as simple as possible, let me give you a head start in case if you know what histograms is. Again, all we're trying to do is create a random multivariate data for us using a pandas data frame, and we're just trying to plot it one over the other as well, right? So, how many lines of code is this, guys? Honestly, this is 4 lines of code, and you have a very complex looking graph. And here, of course, we're trying random data out, but at the end of the day, if this is driving your business analytics, you really do not have to put in a lot of effort to get meaningful insights. That's my approach here, guys. So apart from all of these, now when you think about it, there's so many other things you can do, right? So there's something called as kernel density estimation, or what we call as KDE as well. So you can have smooth estimations based on that. Now with you can see a direct comparison in between a histogram and a smooth comparison, right? A smooth estimation, or a kernel density, or KDE, what we call as, is used to perform a lot of statistical analytics. As you can see, it can be standard deviation, it can be deviations, or any statistical concept usually takes smooth estimations as its output figure as well. So when you think about it, a histogram stands out very much. So if you have a requirement for histograms, yes, it's available. If you want to make use of a beautiful looking smooth curvy if you want to make use of a smooth curvy looking graph where this curve in fact adds a lot of meaning and it's not just aesthetics, then yes, you can use that as well. Now you'll have a question saying, okay, so histograms are good, I can make use of kernel density estimations in a way where I can smoothen things up. Can I do both? The answer is yes. And no, it does not take in 10 lines of code or 12 lines of code. It just takes in 2 lines of code, guys. With 2 lines of code, as you can see, you will understand how kernel density estimation works when it's mapped over a histogram as well, right? So it's a pretty simple thing, pretty beautiful to look at. And trust me, in an actual production environment, right, this can have so much meaning, and you will understand once you're serious about Seaborn, right? So I'm sure you'll be looking into more depth about it. You'll be looking to become a serious data analyst, or a Python developer, or a data visualization professional as well. So when you think about it that way, once you start monkeying around, once you start understanding the in-depth concepts and the offerings that Seaborn offers, right, on the beginner level, on the intermediate level, and even on the expert level, you will thoroughly appreciate the beautiful data visualization tool that it is, guys. So let's say if you want any two-dimensional plotting as well, again, all it takes is 1 line of code. You're going to be using KDE plot. KDE plot is going to give you a basic two-dimensional representation of what your random data looks like, and it's random here because we have considered random data, right? So here you can see that data is equal to PD.data. We have a random multivariate data analytics going on out here. But then if the data is not random, then this graph will make a lot of sense for you guys. But then just for the representation's sake, I have tried to keep it as simple as possible, guys. And then you have something called as joint distribution or joint plots as well. With respect to joint plots, you can actually have multiple distributions on the same screen, right? So this is, let's say, a modified version of what a KDE plot looks like, but then that's dialing it down to a lot simple extent, guys. You can you can have multiple plots. That's basically how it got its name, joint distribution. And with this kind of a data, you can try to look at things which weren't visible to the naked eye previously as well. It's just not this, right? Think about it. Totally, how many lines of code have we put down out here? Most of it is importing the data set. In fact, we seeing the data set, describing the data set, and that's about it. As soon as you're done with that, as soon as your data is clean, your data is ready to use, a data visualization guy steps into the picture and does his or her magic as well, guys. So as you can see, a small amount of code, a very big impact, right? So at any point in time, you can pause this particular video, follow along, and we'll make sure that we'll share this particular collaboratory file as well. So this can be handled as a Python Jupyter notebook file that you can use, import it onto your local Python environment, and work with it as well, guys. So I hope this Seaborn tutorial was very effective for you guys to get started with Seaborn, and and I hope you got to learn a lot from it as well. And with this, you've come to the end of this video, and I'm more than excited to see you on the next one.
We hope the Seaborn tutorial was very helpful for you guys. Well, if you have any other content requests, make sure to head down to the comment section below and do put it down, and we'll have the video up in no time. Well, with that, I'll see you on the next one.